Right now, you are doing something your ancestors never did, something no human being in the entire history of this species did, until about 15 years ago, and your brain has no idea how to handle it. You pick up a small glowing rectangle. Your thumb begins to move. Up, down, up again, a flash of color, a sound, a face, a thought, another face, something funny, something sad, something outrageous, something beautiful. And then, before your brain has even finished processing what it just saw, something else entirely. You didn't choose to keep going, you just did. And somewhere deep inside your skull, in a region so ancient it predates language, predates thought, predates everything you think of as you, a chemical was released and then it disappeared. And your thumb moved again. Here is what no one tells you when you download an app, create an account, or simply reach for your phone out of habit at 2 in the afternoon. Every scroll, every swipe, every tap is teaching your brain something. Not in the way a book teaches. Not in the way a conversation teaches. Something older. Something deeper. Something that operates entirely below the level of your awareness. The question scientists are now asking, urgently, in laboratories around the world, is this: what happens to a brain that was built for survival when it is exposed to an infinite stream of artificial reward? And the answer, the real answer, not the one that fits comfortably in a headline, is stranger and more profound and more deeply human than you might expect. You know the feeling. You sit down with your phone intending to check one thing, maybe a message, maybe the weather, maybe just a quick look. 22 minutes later you surface, slightly dazed, not sure what you just watched, not sure how you feel. Vaguely hollow, like you ate something but you're still hungry. And here's what's strange. You didn't enjoy most of it. Research published in the Journal of Experimental Psychology found that the majority of people rate their phone use as significantly less enjoyable than they expected. And yet, they cannot stop. The wanting and the liking have become two entirely separate experiences. You want to scroll, but you don't particularly like scrolling. That gap, that precise, unsettling gap, is where the neuroscience gets extraordinary. In 1954, two neuroscientists named James Olds and Peter Milner made an accidental discovery that would eventually explain your relationship with your phone. They implanted tiny electrodes into the brains of rats. And they discovered a pathway, a circuit, that when stimulated, caused the rats to press a lever compulsively, thousands of times per hour, ignoring food, ignoring water, ignoring sleep, just pressing, pressing, pressing. They had discovered the brain's reward pathway. At the center of this system is a molecule you've heard of, dopamine. But here's where the story gets complicated, and where almost everything you've been told about dopamine is incomplete. For decades, science described dopamine as the pleasure chemical, the molecule of happiness, the reward signal. But neuroscientist Kent Berridge at the University of Michigan discovered something that changed everything. Dopamine is not about pleasure. Dopamine is about wanting. These are not the same thing. And the difference between them may be the most important thing you learn today. Imagine your brain as a vast, ancient city. This city has been under construction for 200,000 years. It has rivers and roads and markets and towers. And running through the very center of it, beneath the streets, invisible to everyone who walks above, is a pipeline. This pipeline carries a very specific signal. Not information, not thought, not memory, desire. Whenever the city detects something important, food, danger, a potential mate, an unexpected sound, the pipeline surges. A pulse moves through it, and the city turns toward the source of that signal and says, more. This is the dopamine system. And for 200,000 years, it worked beautifully. The surge came rarely. When you found food after days of hunger, when you survived something dangerous, when something genuinely unexpected and meaningful happened, the surge was the signal that said, pay attention. This matters. Do that again. Now imagine someone connects that pipeline directly to a machine designed by teams of engineers, behavioral psychologists, and artificial intelligence. A machine whose only purpose is to trigger that surge, constantly, continuously, every 3 seconds, every 2 seconds, every time your thumb moves. The pipeline doesn't know it's been hijacked, it only knows the signal, and the signal keeps coming. Inside, the body journey. Let's go inside, deep into the brain, past the prefrontal cortex, the seat of your rational thought, past the hippocampus, where your memories live. down into the midbrain, into a tiny cluster of neurons called the ventral tegmental area. This region is ancient. Profoundly ancient. It exists in fish, in reptiles, in every vertebrate on Earth. When you scroll and encounter something unexpected, a surprising video, a confrontational comment, a beautiful image, a piece of news that triggers outrage, the ventral tegmental area fires. Dopamine floods the nucleus accumbens, a small, curved structure that acts as the brain's reward hub. And then something remarkable happens. Your brain doesn't just register the reward. It begins to predict it. Neuroscientist Wolfram Schultz discovered that dopamine neurons don't actually fire when you receive a reward. They fire in anticipation of a reward. The moment before, the possibility of something. This is why the scroll feels so compelling even when the content is meaningless. Your brain isn't reacting to what you're seeing. It's reacting to the possibility of what might come next. The next post might be extraordinary. The next video might change something. The next notification might contain something important. It almost certainly won't. But your dopamine system doesn't deal in certainty. It deals in possibility. And a feed that never ends is an infinite source of possibility that never resolves. Your brain is caught in a loop. It was never designed to exit. Simultaneously, in another part of your brain, something else is happening. The prefrontal cortex, responsible for long-term thinking, decision-making, and impulse control, begins to quiet. Not dramatically, subtly. The way a fire dims when you stop feeding it. Research from the University of California found that excessive smartphone use is associated with measurable reductions in gray matter density in the prefrontal cortex. The very region responsible for saying enough begins to lose its voice. The city's ancient pipeline surges, and the part of the city that knows better goes silent. Emotional twist. Here's the part that isn't in the App Store description. Dopamine, when triggered artificially and repeatedly, does something counterintuitive. It raises the baseline. Imagine a thermostat in a room. Under normal conditions, a modest warmth feels comfortable. But if you blast the heat constantly, if you flood the room with intense warmth every few seconds, the thermostat recalibrates. Now ordinary warmth feels cold. This is called hedonic adaptation. And in the context of dopamine, it means something deeply important for how you experience your own life. When your brain is repeatedly exposed to high stimulation, high novelty, high reward content, the kind that platforms are specifically engineered to deliver, it adjusts its expectations. Ordinary life begins to feel insufficient. A quiet morning feels dull. A conversation without a notification feels incomplete. Reading a page of a book without an image or a sound feels like an effort rather than a pleasure. This is not weakness. This is not a character flaw. This is your ancient brain responding to a stimulus it was never built to encounter. And in that recalibration, something quiet and profound is lost. The capacity to be present, the capacity to find meaning in stillness, the capacity to feel genuinely satisfied by the small, real, unremarkable moments that make up most of a human life. Shocking consequences reach further than you might expect. Studies from Stanford's Social Neuroscience Lab show that high social media use is correlated with increased activity in the brain's threat detection system, the amygdala, even during periods of rest. Your brain, after hours of high stimulation input, doesn't fully return to baseline. It stays alert, scanning, waiting. This is why you feel tired but wired, exhausted but unable to sleep, overstimulated but still reaching for your phone. The body registers this as chronic low-level stress. Cortisol, the stress hormone, remains elevated. Inflammation increases subtly. Sleep architecture changes. REM sleep shortens. And with it, the brain's nightly process of emotional regulation and memory consolidation is disrupted. But perhaps the most unexpected consequence is this. Motivation erodes, not dramatically. Slowly. In the way that fog rolls in, you don't notice it until you can no longer see clearly. Dopamine is not just the molecule of wanting. It is the molecule of drive, of effort, of the willingness to pursue something difficult across time. When the dopamine system is chronically over-triggered by low-effort, high-reward stimulation, the motivation to pursue high-effort, delayed reward goals diminishes. Your brain, in its extraordinary efficiency, is simply making a logical calculation. Why work hard for uncertain reward later when certain reward is available now? The dreams you have, the project postponed, the relationships you've meant to nurture, they are competing. neurologically, directly, against an infinite scroll. Here is what all of this points toward. The scroll was not designed for you. It was designed for your dopamine system. There is a distinction, and it matters enormously. You, your values, your curiosity, your capacity for depth and love and meaning are vastly more complex than the ancient reward pathway running through your midbrain. But that pathway is fast, and it is loud, and it responds before you have time to respond. The engineers who built these platforms understood this before most neuroscientists had finished explaining it. Variable reward schedules, the same mechanism that makes slot machines impossible to walk away from, were deliberately embedded into feed design. The pull to refresh gesture mimics the physical motion of a slot machine lever. Notification badges are calibrated to trigger the same anticipatory dopamine spike as an unexpected sound in an ancestral environment. None of this happened accidentally, and the consequence, playing out across a billion brains simultaneously, is what some researchers now call a dopamine dysregulation epidemic. A slow, invisible reshaping of the human capacity for attention, patience, deep thought, and the experience of genuine satisfaction. But here's the other side of the science, and it is equally important. The brain is plastic. It changes. It rebuilds. It rewires. Research on dopamine recovery shows that even brief periods of reduced stimulation, what scientists call dopamine fasting, though the mechanism is more nuanced than the name suggests, allow the brain's reward sensitivity to recalibrate. The baseline lowers. Ordinary experience begins to feel sufficient again. The capacity for deep focus returns gradually, like circulation returning to a limb that fell asleep. The prefrontal cortex, given space and silence, reasserts itself. The city's pipeline slows, and in that slowing, in that quiet, something ancient and human reemerges. The ability to want something that takes time, to find meaning in something that doesn't move, to sit with a thought long enough to understand it. This capacity was never lost. It was only drowned out. There is something almost poignant about all of this. Your dopamine system evolved over millions of years to help you survive, to drive you toward food, toward connection, toward discovery, toward the effort required to build something lasting. It was, in its original form, a compass. It pointed toward what mattered, and now it has been pointed at something that matters infinitely less. And it cannot tell the difference. It only knows the signal, and the signal is louder than it has ever been. But you can tell the difference. That is the extraordinary thing about being human. You are not only your ancient pipeline, you are also the part of the city that can look at the pipeline and ask, where is this leading me? Every time you set down the phone, every time you sit with discomfort instead of reaching for stimulation, every time you choose a difficult thing over an easy one, you are not just making a lifestyle choice. You are speaking directly to your own brain. You are saying, this is what matters. Learn this, reward this, build this, and slowly, quietly, cell by cell and synapse by synapse, it listens. The question has never been whether your dopamine system can be reclaimed. The question is whether you believe your real life, the slow, quiet, imperfect, unremarkable, extraordinary real life, is worth reclaiming it for. Perhaps it always was. Perhaps you already knew.